Okay, all right, so we are going now. So let's talk about factoring with the AC method. I'm Chuck Newberg, professor here at Mathematics. Welcome to the MAC today, the Math Advancement Center. And the first thing I thought I'd talk about a little bit is what is factoring to begin with. So let's look at multiplying these two polynomials here. These two what? Binomial times what? Binomial. And remember, a binomial is two terms, 1, 2, 1, 2. So I have a binomial times a binomial. And so let's remember, we use our favorite four-letter F word when we multiply these out. We're going to FOIL them. So come on in, come on in. Thank you. So let's look at 2x minus 3, 3x plus 5, and let's go ahead and FOIL them. So FOIL stood for what? First times first. So I'd have 2x times 3x. Well, 2 times 3 is 6. I'd have x times x, which is what? X squared. And remember, x times x really means x squared. An exponent is a fancy way of what? Hiding repeated multiplication. All right, so that's first times first. Outside times outside. 2x times 5. Well, 2 times 5 is 10. And we still have x to what? The first power. Then that's outside times outside, inside times inside. I'd have a negative 3 times 3x, which is a negative 9x. And then last times last, negative 3 times 5. Well, negative times positive is negative. 3 times 5 is 15. So if that's what we get when we multiply them, and notice what we have here. We have 1, 2, 3, 4 terms. That's because you have 2 times 2, and there has to be 4 combinations. Now, what can we do with these two? These are what? Like terms, right? If I have 10 of them, I take away 9 of them, I have what? 1 left. So I get 6x squared plus x minus 15. So we have this expression equal to this expression. And let's show that down here. So when we went from here to there, we call that what? Multiplying. And our technique for multiplying is what? FOIL. Now we got to start here and what? Come back to what? Here. So I'm only going to show one method. I'm going to show what's called the AC or the grouping method. And the trick is we have 3 terms here. Well, we really would like to have 4 terms. So what we're going to have to do is figure out how to split this middle term so we can have 4 things. And then what we're going to do is we're going to group 2 things together. We're going to group 2 things together because it's way easier for our brain to what? Look at 2 things than to look at 3 things. We can see a common factor the more than we can see a binomial times a binomial. Okay, so that's our approach. To go from here to here, that is called factoring. So let's look at our next slide. We're going to look at factoring these type of polynomials here. An ax squared plus a bx plus c. We know from previous we called this a quadratic polynomial, a quadratic polynomial. I wanted to call it a function. It's not as a function right now. These are the ones that pop up often because when we model things, turns out the quadratics are one of the biggest modeling functions. All right, so what we should discover is that they are always going to multiply into a binomial times a binomial. Now I use Greek letters here. Why did I use Greek letters? Because I could not get a box to work in PowerPoint. Don't worry about the Greek letters. What we're really going to try to do is figure out what those Greek letters have to be. And they're not that important. Don't memorize alpha, beta, gamma, and delta or anything like that. We're just going to figure out the technique. So we got to get a binomial times a binomial. So the AC test. And the cool thing about the AC test is this will tell us, is it going to factor or not factor? So a trinomial of the form ax squared plus bx plus c is factorable if and only if there are 2 integers. And we're going to call those integers m and n. There's nothing really special about those variables, such that when you multiply m and n together, you get a times c. Now remember, what is the a? The a is on the x. The c is the constant term. So we're going to multiply the coefficient on the x squared term times the coefficient or times the constant term. That's our a times the c. We got to find 2 numbers that multiply to that, and they have to add to b. The b is what? The middle coefficient. So we're going to look at finding 2 numbers that multiply to a times c that add up to that middle coefficient. So, and if you cannot find them, then we say the polynomial is not factorable, or we say the polynomial is what? Prime. So the cool thing about this test is, once you've tried all the possible combinations, if there's none that works, then you know it's what? A prime polynomial. You can't break it apart. And remember, like, what's a prime number? A prime number is where you can only write it with two distinct factors, one in itself. It's equivalent. Versus 8 is not prime because I could write it as 2 times 4, or what? 1 times 8. It has more factors. Okay, so let's look at the AC method now. The AC method, or the AC grouping method, it has other names. Here's our steps. Step 1, factor out any common factors of the expression. If there's something common, like a 2 and everything, you want to pull those out because the numbers stay smaller. Compute A times C. That's the coefficient on the x squared term. C is the constant. You want to multiply those out. And then you start your look. And you look for two integers. Remember, integers are the whole numbers and their opposites. 0, 1, 2, 3, minus 1, minus 2, minus 3. We're not using fractions. Nobody panic about the fractions. And we got to look at m times n. We're looking for two integers that multiply to A times C and add up to the middle coefficient. All right, so after we find those two, we're going to split that middle term up into two terms. And remember, what we're trying to do is we're trying to take this and we're going to split it up into two so we can work our way back up. And then we're going to factor by grouping. And we've seen factor by grouping before, but we'll show it here again when we do this. And then after that, we're done. We just got to write the final answer. Don't forget any common factors that you may have already, factored out. Okay, so let's take our first practice problem. 6x squared plus 13x plus 6. And the first thing I'm going to do is make sure we identify our A, B, and our C. So we have 6x squared plus 13x plus 6. Let's recall, this is our A, this is our C, and our A is 6. For some reason I thought it was 13 there. Okay, so the first thing we do is we compute A times C. A times C, 6 times 6 is 36. Now I'm going to start off with a table here to see it, but later we'll try to do a little mental math. So we're going to look for two numbers that multiply to 36, and then they have to add up to B. Our B is 13. So m plus n have to add up to 13. Now you could start listing them all out if you need to, and that way you can say it's factorable. But if your number sense is already turned on what it is, that is awesome. But let's list them out here. So I could do 36 as 1 times 36. What do those add up to? Those add up to what? 37, right? Is that 13? Yeah, I usually don't even write it out. Then what? 2 times 19, those add up to what, class? 21. That's too big. Notice we're getting smaller though. 3 times 12, what do 3 times 12 add up to? Those add up to what? 15. We're getting closer, so I'm feeling like maybe I'm getting there. Next one would be 4 times 9. And what did 4 plus 9 add up to? They add up to 13. Is that what I'm looking for? It is, right? So what does that do? That makes me happy because now I found what I got to split. And anytime you're happy in math, that is awesome. All right, so let's do our split now. Let me clear up some of this space here. I have 6x squared plus 13x plus 6. Now I'm going to split this up. I'm going to split it up as 4 and 9. So I'm going to resplit this as 6x squared plus 13x can be thought of as 4x plus 9x, because 4 and 9 add up to 13, plus 6. So if you look here, what have I done now? I've generated 4 terms. And I'm going to group the first two together. I'm going to group the second two together. Now my goal is just to pull out any common factors of the first group. Well, let's look at the numbers. 6 and 4. They both have a 2 in them. So I can pull out a 2. Here I have x squared, which really means what? X times x. Here I have an x, so they both have an x in them. I can pull that out. Well, 6 goes into 2, what? 3 times. I had x squared. I pulled out one of them, so I still had an x there. 4 goes into 2, 2 goes into 4 2 times, and the x is gone. Now let's go to our second group. Here's our second group. 9x and 6. Well, what do they have in common? They have a 3. They don't have an x, but they have a 3. I'll pull out a 3. And here, what do I get? I get 3x from there. 3 goes into 6 what? 2 times. Forgot my plus sign there. And I'm working on a limited board space, so let me erase this here. And now if you look, what do we have here? We have group 1. We have group 2. Do we see anything common? And if this works out right, you should see a common set of parentheses. And we'll factor that out. And when I factor that out, and I'll factor it out to this side, it doesn't really matter, but it looks like it's more on this side. That's why I do it. When I factor out the first term, what do we have left? The first group, excuse me, we have what? 2x. And when I factor it out of the second group, what do we have left is what? That plus 3. And what have we done? We have gone from what? This polynomial to what? This here as its factoring. All right, so that's the AC method. The trick is figuring out how to split. And then after you got it split, you have to have this common binomial factor. Every once in a while, it won't work out, and then you have to flip those two. Because you know it's factorable if you found m and n, but every once in a while you'll have to flip these two. It's pretty rare, but every once in a while it does pop up. All right, so let's go to our second problem here. And our second problem, you notice, doesn't have an a. Oh, what would make a disappear? What's the one number you can multiply by that you sometimes don't notice? Marie. 1, right. So we could think of x squared minus 7x minus 6. We could think of that as a 1. We don't normally write that there, but 1s are placeholders in multiplication. 0s are placeholders in addition and subtraction, but 1s hold a lot of place. So let's find our a times our c. Our a times our c is 1 times negative 6, which is what? Negative 6. Okay, so what have I drawn here, class? I've drawn you. We're doing a little mental math now, because sometimes it's nice to think about these. As you do these, you'll start to realize, oh, I can step back and do a little mental math here. So we already have a times c to be negative 6. I want us to think about m plus 2 numbers that multiply to negative 6, and they have to add up to negative 7. So that's what we're thinking. So sometimes we like to think about these. So let's just think about those for a second. First off, everybody get their 2 numbers that multiply to negative 6, and they got to be negative. Well, one might be negative 1 and 6, right? What do those add up to? 5. If you reverse them, they'll also add up to what? They'll add up to negative 5. How else can we get negative 6? Negative 2 times 3, right? What do those add up to? Those add up to 1, or if I reverse them, they add up to negative 1. Do we find any that add up to negative 7? We didn't. Have we used all the factorings of negative 6? We have. So what's our conclusion here? This polynomial is prime. All right, so that can happen. All right, so let's go to our next example. Sorry, I meant to do the mental, oh no, we're not doing a mental math on this one yet. We have one. Okay, so let's look at this one. Now I will point out, students, I get very excited sometimes to jump into the math, and sometimes I forget. We should always start at step 1, looking for a common factor. If we went back to the previous 2, I got so excited I forgot to point out there was what? No common factor, no common factor. Now how about 30, 56, and 10? Are those 3 numbers even? They are, right? So we know a 2 goes in there. Could a 4 go in there? Well, 4 does not divide 10, so it can't go into all of them. So we'll start by pulling out a 2. 2 goes into 30, what? 15 times. So I get 15x squared. 2 goes into 56. Well, if you think of 56, it's 50 and 6. 2 goes into 50, what, 25 times. 2 goes into 6 3 times. 25 and 3 add up to what, 28, so I get 28x. And 2 goes into 5 or 10 5 times. Those that don't know this is called breaking and bridging. It's a faster way than getting out your calculator. So now we're going to do the AC method on this here. And then what do we got to remember in the end? Put back our 2. So let's clear up some space here. And let's do our A times our C. Our A times our C, 15 times 5. Well, 15 times 5, I think 15 is 10 and 5. 5 times 10 is 50. 5 times 5 is 25. 50 and 25 add up to what? 75. So that's one way of doing that multiplication. So now what do we have to do? We have to find factors of 75 that what? Add up to the middle coefficient. And the middle coefficient is not 56, it is what? 28. So we're looking for 2 numbers that multiply to 75 and add up to what? 28. So let's go through there. Well, 1 times 75, that's not very interesting. That's 76, by the way. 75, is it divisible by 2? No. Is it divisible by 3? It is. And if you don't know the test, add up the digits. 7 and 5 is 12. 12 is divisible by 3, so 75 is divisible by 3. 3, let's see, 60 is 20 and 15, so 23. What do those add up to? Those add up to what? 26? Did I get that right? 3 times? 25. Oh, thank you. Woo. Oh, man, that was, I almost had a heart attack there. Thank you there, young man. What do 3 and 25 add up to? What do those add up to? I'm having issues today. 28. Does that make us happy? Yeah, that's what we needed. So now we'll split. Now, I usually like to do this as some scratch work. There's nothing wrong in college that says, hey, you can't have a little scratch work on the side. So I'm just going to take 15x squared. I am going to split 28x up. And I have 3 and 25 to use. I don't know, I might want to put the 25 here because it goes well with 15. So I'm going to put the 25x here. I'm going to put the 3x here for our 28. Then I still have to remember what? The 5. And I might have to flip these two if it doesn't work. I know it has to factor. Why do I know it has to factor? Because the AC test said it had to factor. We have found the 2 numbers. So let's group the first 2. Let's group the second 2. The plus goes there. If this was a minus, I'd have to put a plus in there. Hopefully I have one of those examples picked out. If not, I'll put it in for next year's. 15 and 25 have a 5. X squared and x have an x. 5 goes into 15 3 times. We had x times x. I pulled out 1, so I still have 1 left. Here I have 25x. I pulled out a 5x. So 5 goes into 25 5 times, and the x is gone. And here I have 3. Oops. Now here, sorry, I got so excited. 3x plus 5. Is there anything common? There is always one number that goes into every number. 1. Sometimes you have to pull out a 1. 1 is a placeholder in multiplication. I get 3x plus 5. Now what do you see? Do I have a common binomial factor between the groups? I do now. So what do? We pull that out. And when I pull out the 3x plus 5, what do I have left on the first term? I have left in the first group 5x. What do I have left on the second one? I have what? The plus 1. And notice you need that plus 1 because otherwise you would never what? Generate back that group. If it said it was a 0, there's nothing common. Well, there's always something common, the number 1. All right, so we're doing good on time. Oh, thank you. So this is the other thing. Now the reason I love teaching is I always have a group of students to catch all my little mistakes that I make in my old age. And this is one of them. I got so excited, I'm done this, I want to go to the next problem. I forgot, I got to go back step 5 and write the final answer. The 2 is still here. This we just said is this. And there is our final answer. Thank you, young lady, for letting me work something in correctly. All right, questions on those? let's do one more. And I'm going to give everybody a chance to try this one. Let's look at 3x squared plus x minus 4. I'll let you try the a times the c. See if you can come up with that split mentally. And I'll get the whiteboard or the chalkboard cleared up. I'll give you a minute or two. Find your a times your c, identify your b. So we'll go back. Here you are. Your brain's even gotten bigger today just by watching this video. And so what do you do? A times the c. So I'd say, oh, 3 times negative 4 is what? Negative 12. And then I have to find two numbers that multiply to negative 12 and add up to a positive 1. Ooh. Well, I know 3 times 4 is 12. One of them is going to have to be negative. If I made that negative, I'd have 3 plus a negative 4, which would be negative 1. And what do I want it to be? I want it to be what? Positive 1. So what do I got to do? Switch the signs. It's going to be minus 4 and 3. So some of us can come up with that mentally, and then you'd say, okay, I'm going to split that. And even this 4 kind of helps. I might want to put the 4 with the 4, and I said I'm going to split it as minus 4x plus 3x. So I'm going to go with minus 3x plus 4x minus 4. And you should always check to make sure these two add up. And that's actually, if you saw a little pause there, I was actually adding them up to make sure I didn't make this mistake. Minus 3x plus 4x, what do they add up to again? They add up to x. Now we group the first two together. We group the second two together. What's common in the first group? 3x squared minus 3x. I can pull out a 3x. From here, what's left? An x. What's left if I pull out everything? 0? 1, right? And it'd be a minus from there. I'll go with awkward silence. Then 4x minus 4, I can pull out a 4. Leaves behind an x. Leaves behind a minus 1. Do we see our common groups now? X minus 1, x minus 1. So we can pull that out. The x minus 1 goes there. When I pull it out of the first group, what's left? 3x. And when I pull it out of the second group, what's left is a plus 4. All right. So that is the AC method. Now, you might have had your teachers teach you some variations. You might have, if you're from Evanston High School, they might have taught you to do the cross box. That is the AC grouping method. So those Evanston High School teachers have had this for a bunch of years. So I was always excited the first time I saw it. So, and there's variations of this. So if you've seen this before in a different variation, just realize it's just a teacher's algorithm that's showing you how to do it. So, all right, thank you. And let's see, I think I have one more slide. Oops, I hit blank there. So, questions. Do I have any questions from the audience? All right, well, thanks for visiting the MAC. Be sure to attend future math talks and have a great day. So, thank you.